Ralph Tuccio can take his mask off.
Yeah, because we don't want to look at you.
No, it's your schnozola.
Okay, can I turn these off? I'm just gonna put some mood here.
Actually, that was parked. Actually, that was parked during which is long and tedious before a pipeline was established. We took this problem into consideration and built a system around it to combat this. So in the process of building our motion capture pipeline, we looked into various different systems that were built at CMU. However, most of them were either too
No idea.
complicated or took long in the cleanup process.
That's the size. You have a very bright background for size. So it's real up. What is that doing?
So Tuesday, Brad and Melissa are on
And here we found that the system that was about the ETC, the perception neuron therapy system, was not only the most easiest to use, but also the best and our first step.
Very trees.
Actually, that was better during quarters as cleanup time. It was long and tedious before a pipeline was established. We took this into consideration and built a system around it to help combat this.
So the break is coming at the right time.
In our process of creating a woodcutting system, in our process of creating our motion capture pipe, to various different systems, like let's see forms that we felt either too complicated or too long in the process. In the end, we found that this system the perception neuron therapy worked despite being
No, sir.
just a pipe.
Nope, we're anti-pickup trucks.
Just a lot of pickup trucks in Texas.
There's just so many. They always tail you too, and then you're like,
Displayed in the rack on the back.
the lights. But I grew up in Seattle, so we're coming from the west coast of Texas, so it's a little bit of a different perspective.
Well, we're in for an adventure.
Oh, yeah. Are you going to Texas?
Outside of Austin, so
Oh,
I was like, we're going to see some other parts of Texas.
Mm-hmm.
Who knows?
I almost took a job in Houston. Didn't though.
I did a bunch of work for Rice University.
You're a good firm.
Yeah, we're timing it, so it's only, that's a strange place. It would rain for 15 minutes, really, the flood, the roads would be, it'd be like 2-3 feet of water, it would be like 15 minutes.
Oh, it's really sort of.
That's exactly right. That's all Houston is built from this water.
All right. We've got our first team ready to go. Some teams in the room. So, just us. All right, so it's Halves. So producers keep an eye on me for time, and then we'll do Q&A. And we got 7 this morning. Portal Harmony, Telepathway, Training Game, Blue Farmers, Hermes, and
Your link to the morning thing might be the wrong way.
I'll double check.
I keep getting the afternoon, but yeah.
He'll fix it. All right, whenever you're all ready.
Hi, good morning. We're Portal Harmony, and this is our half presentation. I'm Tuesday, and I'm the director and co-producer.
I'm Sandra, character artist and co-producer too.
I'm Rick. We have 5 artists and programmer.
I'm Joy. I'm the artist on the team.
And I'm Shinu. I'm the animator, rigger, and motion capture handler on the team.
And the song we're using is This Time by Brightside, a local Pittsburgh band. And we're collaborating with Attack Theater, which is a local dance company. Peter Cope is also associate professor of dance at the School of Music. We've been collaborating with them, showing them storyboards and hearing what their interpretation is of the song and the lyrics, as well as any ideas for special like support for parts in the storyboard that will support movement, specific movements. As a refresher for our goal, we're linking Unreal Engine and motion capture to produce a roughly 3-minute animated music video. We're going to talk a little bit more about our feedback from quarters. During quarters, one of the main concerns brought up was our metrics and what we're prioritizing as a team. Entering this project, we knew that the first priority for us was gaining experience within virtual production tools such as Unreal Engine and linking motion capture. Unreal Engine has traditionally been used as a game development tool, though in recent years it's been embraced by the film community, often for previs and real-time rendering. And its accessibility has allowed indie filmmakers to large productions such as The Mandalorian to produce pieces. And storytelling and art are also very important. And we went through about 4 to 5 iterations of storyboards and made adjustments based off of talking with the dancers. And I met with Brenda, who helped me kind of direct like what was missing in the piece or what was missing in the story, and make adjustments based on that. A question brought up during quarters by Chris Klug was, how are we measuring success with our storytelling? And he had suggested doing test screenings where we asked them questions about plot details and character motivation after they've seen the piece. So we're hoping to do that once we're further along in the process. And Sheena will talk a little bit more about another concern brought up during quarters.
Thank you. Yeah, another issue that was brought up during quarters was cleanup time, which was long and tedious before our pipeline was established. We took this into consideration, and we built a system that would help combat this. And I'm going to talk about this later in the presentation.
So we're just wrapping our pre-production phase up. These are a couple of storyboards to kind of show you what we're visualizing. The logline is the burnt-out artist is teleported to an alternate reality and must reconnect with her sense of curiosity in order to reignite her passion for painting. Now Sandra can talk a little bit more about art.
So after quarters, we got concerns on art styles and scope with how many art styles we have to work on. So we have discussed with Rolf and Mo about the art styles and different assets, what we should be working on. So for now, the characters are down, and also we are focused on different 2 aspects of art styles. So for indoor environment, we're going to be more stylized, and for outdoor environments, we're going to be more feel realistic. So there are 2 words in total. The outdoor environment is going to be inspirations of Emma's head. She's one of our main characters. And here's the layout of our room. And also here is a demo for the room too. It's rendered from Unreal, and so if you can, something we are hoping to present in the future.
This is one of the scenes of our music video, and this is where our main character lives. And we're gonna add more and more details to support the storytelling.
And here is our character arts. So it's fully retouchable and being rendered good for rigging. And we already started to painting it. Since for right now, it can be importing data from mocap directly to the character. And now here is something about stylized materials where I'm currently working on. You can see this high poly model was directly from ZBrush and by the sculpting. And the one on the left is something from Substance Painter, so it's a low poly model with texture on it, and it should be fully rendered in the future.
As for the production stages, we have 3 different parts. For part 1, we use Maya and ZBrush to do the modeling. That is pretty similar to the traditional animation pipeline. And then we use perception neuron system to do the motion capture and have the data back to Maya to clean up. And for part 2, we use Houdini to do the VFX and bake the data into Unreal Engine. And finally, we put things together in the Unreal Engine and render the animation and use After Effects to do the video editing.
So in the process of creating our motion capture system, which involved the perception neuron software and Maya and Motion Builder involved, we looked into various different motion capture software that was available at CMU. However, we found that most of them were either too complicated to use or took too long in the cleanup process. Fortunately, we found that the system that was already available at the ETC, which was the Perception Neuron 32 system, although despite being really old, being 5 or 6 years old now, was not only very easy to use, but also worked best in our 4-step pipeline. So our 4-step pipeline consists of 4 steps, of course. The first step is we take the motion capture data, which is in FBX form, and we import that into Maya. And then after that, then we assign that data onto Maya Motion Builder skeleton, and the skeleton will help preserve that data. And that's also the stage when we make any kind of corrections that were, if there's any errors during the tracking process. And then once all those are corrected, we take that data and we assign it to an already rigged and skinned character model. And finally, once everything looks good with that character model, with the animations and movements, once everything is all corrected, we finally move on to the 4th and final step and bake that data permanently onto the model and export that character animation as an FBX, where it will be used in Unreal. This is a really good system which was tested. We did like a 3-minute long, we tested it on a 3 minutes long worth of motion capture data, and something that would usually take about like a few days or maybe even a week with using like traditional pipelines. Our pipeline, we could do it only in a few hours.
This is a preview of our asset protection. First, we're gonna modeling all of the asset in Maya and then bring them into Substance for look development for material and shaders, and finally bring them into Unreal Engine for the final rendering.
As for the VFX, we simulate them in the Houdini and then export it to Unreal Engine. For example, for this ground disruption effect, we simulate the physics in Houdini and bake the data into geometry cache and export it into the Unreal. And for the flame particle effect, we render the flame in Houdini and bake it to texture sheet and combine them in Unreal.
This is the preview of our mocap data transfer into the animation and finally testing on one of the other scene. As you can see, the motion is pretty good and pretty smooth, and we're gonna use a lot more cameras and move them inside the game engine to improve the visual looks.
So plans moving forward, we have a motion capture test date at Attack Theater on March 10th during spring break. During this test, we're going to try to capture movement that was unable to do with ETC, such as working on with crash pads and assisted lifts and rigs with nets and trampolines. And our official motion capture date is on March 15th, the week after spring break. And then following that will be in-camera or camera settings within Unreal Engine and editing and rendering finally, yes.
I'm very special. Thank you for all the faculties who have helped us. Rolf, Scott, and Mo, and Brenda, Chris, thank you very much. And then summary, thank you for our amazing instructors, giving us a lot of feedback on everything. So valued for technologies, valued for innovations. And we are more getting over art and storytelling. And thank you. We're welcome to any questions and suggestions.
I know we had talked about ways to test the storytelling. It struck me listening to your presentation that you might want to consider both tests of the music and the animation and do that separately. Because
that's smart, yeah.
Yes.
So why didn't we hear any of the music? I'm a little surprised to not hear anything in this half presentation.
So it's a little bit concerned about timing. It's roughly 3 minutes music. So if I just like play along with music and stand here doing nothing, that's probably not a good idea for us. Yes.
They were nice effect demos, but how do those map to the piece since we didn't really get into the storyboard? Like, how many effect shots do you have? What do they entail?
Yeah, for that part, because we know a lot of visual effects are gonna involve in the transition part for each scene, we're gonna have tests. As you have mentioned before, we have been testing for a 15-second slice, and we are working on one of the final transition for the video. And after testing like the scope, we're gonna discuss how many transition gonna have a special effect, and we're gonna move from there.
And also for Adam, we're trying to using VFX to represent some emotional changes, such as breaking out from limits and breaking out from her heart and curiosity. And some of the special effects may help with the fire in the fireplace. And some of those butterflies effects we're trying to working on is trying to not fly into her face and represent like sudden translation between scenes. That's what we are using VFX for.
I guess looking to the rest of the semester, what do you think are your biggest challenges? What are you most worried about?
The biggest thing is about mocap itself. So we're having professional dancers being in part of the mocap animation. So we hadn't yet started working with them. So we have to run testing first with the professional dancings. And then we have to worry about mocap system. Cleanups, not timing. It's nothing about timing, but we have to worry about like transition between cameras, combine everything in the same. This biggest challenge is like going back and forth between the different softwares for us right now.
Time for one more? All right, thanks, team.
All right, thank you guys so much.
Thank you.
Thank you.
Hi everyone, we are Team Telepathway. Our project is about the interactive 3D visualization for machine learning. And these are our team members: Bokang, programmer and producer; Jennifer, programmer; Anlan, artist; Jack, programmer and tech artist; Leah, UI UX designer; Riz, designer and artist; and Yigang, producer, designer and sound. So Telepathway is a project working with Google at the Carnegie Mellon University Entertainment Technology Center, discovering how 3D data visualization and interactions can be used to represent the high dimensionality features of machine learning models in an engaging environment. So we focus on 3D data visualization, combining machine learning using interactive explorations to deliver an immersive and engaging experience for our users and players. And as a Blue Sky and Gift project, we don't have a specific client, but we are lucky to have Google as the partner and the expert. At the same time, we are also a discovery project.
So for the related areas, we basically found two basic kinds of related works. One is kind of for virtualization form for machine learning, and the second is the interaction experience for machine learning. And so about previous ETC project, we found that one is the AI playtesting. The objective of this project is to use AI agents to playtest and subsequently help balance card games. And the other is AI09. It simulates AI through mini games. It focuses on the application of AI, not models. So what we got from this previous work is that what I use in these works is about deep learning networks models. It is about interactions on web pages to show the models and the data, basically 2-dimension, and about arts inspired by machine learning. And the problem with them is that it is kind of hard for naive users to understand machine learning models. And it is kind of lack of immersion. So what we learned from it is that interesting interaction attracts people, and immersion is very important.
And for the culture workaround, at that time we are a little bit lost because it's such a blue sky and discovery project. So the mainly feedback for us from the culture is that to find our way first, find our specific goal and target users. So we did more research, and we also have weekly meeting with Google and our instructors. And finally, we find our goal. Is that to make a visualization which is fun to play and discover how to make audience be engaged when explore visualization and machine learning. And we also decide to choose people who are in higher education as our target users, and we will explain more later.
And since our project is a discovery project, so we defined an overall hypothesis for the whole semester to discovery, which is engaging interactions can help people better understand the machine learning and data science. So here is our method. First, we will divide the big goal, big hypothesis into multiple sub-hypotheses, and we will create 5 to 6 prototypes related to that sub-hypothesis. And for each prototype, we will focus on different directions, different areas about machine learning models, data set, platform, and interactions. Finally, we will conduct user tests to check whether the hypothesis is correct and got our final result. And our final deliverable is 5 to 6 prototype plus documentation to record our finding. And here is our matrix, which is prototyping, innovation, interactivity, and the documentation. And here we are talking about our progress.
So now I'm going to talk about the progress we made. So we finished our sprint 1, and for sprint 1, we created 2 prototypes and conducted user research. We will come back to this timeline and talk more about our future plans. So for each sprint, we structured is that one sprint has 1 to 2 prototypes, and then we have user testing for that. So for this sprint, we focused on K-means algorithm, and K-mean is a technique for data clustering using machine learning. It's capable of classifying unlabeled data into predetermined number of clusters based on similarities, and the K number of clusters represent the K value in our prototype. So as we mentioned that our overall goal is to make experience engaging. So we created this hypothesis, and we tried to prove it with our 2 prototypes. So first is non-traditional data is more engaging to explore than traditional data. Customization enhances user engagement. Literal representation of models help user engagement. And lastly, confusion detracts from engagement. We will also come back to this and explain how what's our answer for this hypothesis.
Yeah, so this brings us to our first demo. So this is the painting demo, because the K-means is somewhat hard to understand. Basically, we had people upload their own image. They pick the number of slices. Here it says 10 that they're picking, in case you can't see. Then you click visualize, and it generates a model of that grouped by color. So these controls let you manipulate this image, and its spread is controlled by the user. But basically what's happening is XYZ is typically used to cluster things physically in space, but instead we used RGB, but used the same data per pixel. That got us these kind of individual slices, which as you see are kind of separated by a single color. So it's basically color proximity that we use to divide these things, and that lets us see the k-means. So we're gonna upload a galaxy painting picture here. So it doesn't just work with paintings, obviously. And we're grouping each slice by the amount of pixels in each group. So in this one, you'll see a kind of like typical extrusion that happens because of that, which is really nice. And when people split it up, it created these wow moments for people when they saw all the colors kind of striated out like that. And this is a really effective way of showing k-means as an output.
So our target demographic is, as we mentioned, people in higher education. And to test our prototype and conduct user research, we set 2 different groups. One is preferred audience group, so the ETC students who have prior knowledge in machine learning, and the other group is general audience ETC students who don't have any prior experience in machine learning. So thankfully, when we conducted playtests, 26 people came to playtest our prototype, and 12 people were the preferred audience, and 14 were the general user. So the overall structure was 10-minute interaction / gameplay, and then 10 minutes to fill out the Google form. And we asked them questions about their engagement, their understanding, and some challenges. And because we had 2 prototypes based on same algorithm, we were able to ask them questions comparing the 2. So these are some insights from the painting deconstruction prototype. So first, by giving freedom to upload images, people were more engaged in the process. Second, it was just generally fun to play with. There was like a wow moment when the painting layers were splitted. And lastly, a lot of people wanted to see this move forward in XR platforms. Of course, we got some feedback, and we actually implemented this feedback for our next prototype that we will show soon. And the first feedback is providing a clear guidance, so like step-by-step UI, showing like what to follow, which one to click, can help the process move more smoothly. And second feedback is adding a loading bar when the painting is or the image is being processed, and breaking up the dense block of text might help people to understand the context better.
And then we are going to introduce our second prototype, which is a k-means garden. So in this prototype, we use flowers, the sprout, as the virtualization of the data point. So it is focused on show how the k-means algorithm work. So at the beginning, the user can double-click the garden to plant some sprout, which means they create some new data points. Also, they can click the sprout to see the details, like the XY value. And then they can choose how many flowers they want to see. This is the k value in the k-means algorithm. And then they can choose some initial point. They are the initial mean point for each cluster. And then the algorithm starts. So for each data point, the algorithm will calculate the distance between this data point to the other mean point. So it will assign this to the nearest cluster. And also, the user can pause at any time, so they can see the details of how it calculation. And then after the first round of calculation, the next step is calculate the mean point for each cluster. And then the algorithm will repeat the above steps until the cluster doesn't change. So we also add a faster button so the user can move the progress faster. Yeah, that is our second prototype.
So here are some insights for the garden prototype. So by splitting paragraphs and providing step-by-step instructions, people understood both data and the algorithm better. And everyone who played garden prototype has a much higher understanding of the data and machine learning, because we have a clear explanation of each step for people to do the interactions. So through the video, you can see the animation pops up when the user double-click the sapling. It helped people to enjoy the learning process and feel interesting to do the interactions. We also have some other feedback, which is some problems we need to solve for next spring. Some people mentioned that even though the animation was engaging, it did not help for understand the data better. And even though we built the scene in 3D, users mentioned that it still feels like 2D. The feedback allowed us to think about what type of data might be better to represent in a 3D environment. And besides, there's less freedom compared to the painting example because people need to do each step by following each instructions we gave.
Okay, so what does this mean for us? Because we're a discovery project and we're not in the business of making prototypes. So we looked at the things that increased engagement. And we want to replicate those things moving forward because that's kind of what we're trying to do. So customization was really key. People liked when they could just put some of themselves into the project, when they could upload their own image. So we're going to have customization built in. We like those wow moments because it really sealed the deal for us. So we're going to try to create things as a pinpoint for a wow moment. We're going to use immersion kind of tactfully so that people can kind of feel like they're part of it and maybe use XR in the future. We're going to scaffold people through the process in the future. We're going to encourage those aha moments when they really get the process because that's what actually got them excited. And we're going to try to like have those moments of appeal again. Oh, sorry. Thank you. Concrete metaphors was a no-go. We picked a flower, but it was too strong of a metaphor and we lost people. So no more concrete metaphors for data. No more pseudo 3D where it looks 3D, but it's not really and it's projected. Low agency for people was a huge problem, and they'll just click around if they can't do something meaningful, and it will crash the program, we've learned. Sorry if you're one of the people in the audience who did that. Text density was a huge problem. We're going to reduce that just physically. And paragraphs on the other side is a big deal. No paragraphs. People hate reading, shockingly. Impatience was a big problem, as I mentioned before, and low self-relevance. So if it didn't matter to me, why do I care about this prototype was a big issue. So we'll make it matter to people. And so just to kind of reflect on the hypotheses then, yes, non-traditional data was more engaging than the traditional axial data. Yes, customization did increase engagement. No, literal representation was not useful, and confusion did detract from engagement. So in the future prototype for this next one, we're going to have loading bars, shorter info text. We're going to have data denoising, so just the data, and then we'll add details later, no axes that are going to confuse people. Info will be opt-in so that people can encourage learning that way. We'll reward exploration so that people can interact the whole time and then get something out of it. And then we're going to try to bring in more interactivity so that they can be doing something the whole time. And so this leads us to the plan for the next sprint. So we start with k-means as a sort of ML style experimentation, but this time we're going to use a data style experimentation and work backwards. So this one's sound and music, and immersion is going to be focused on in that. So music as input is going to be a really big deal. We're going to try to use music, bring it in, convert it to MIDI, and then render an environment proactively from that. And then the second prototype is going to be music as output. So we're going to use machine learning to kind of interpret what a person is doing and then generatively create music as a result of that. So this is kind of our focus for the next sprint. That leads us to our timeline. So you can see that we're kind of at halves, and we're going to do 2 more sprints of development and then document everything after softs officially. So that's what we're doing. This is what's up next, and we're open for questions. Thank you very much. Yes, Mike.
So with your first prototype, did you let the players adjust K, and did they learn that a very low K doesn't do interesting things, a very high K doesn't do interesting things? Did they learn something about that?
Yeah, so the question was whether or not our first prototype let users choose K and if they learned something from that. And so, yes, actually, we did let them pick K from a value of 3 to 20. Anything less than 3 would sort of break the system, because sorting into 2 groups will never really work out. And above 20, it was just kind of an unnecessary detail that was being added. But yeah, people realized that certain things worked better at certain K values. But something like a pixel, I'm not sure if you saw when we were scrolling by the images for samples, but one of them was Mario, which is like an 8-bit, 3-colored sprite. That worked actually really well for low values. But something that was a higher value target, it didn't work as well to separate into 3 groups unless you're trying to get rough clusters. So Starry Night in 3 clusters looked like a foreground, a midground, and a background, which was pretty cool. And the stars kind of popped out. So there was some benefit to having low values of K even with a complicated image, but people understood generally what they were trying to go for, and they had an output in their mind when they uploaded an image, and they saw how well that was actually recreated at the end. Any other questions? Yes, true. Oh, sorry, Dave. Yes, I know who you are.
So you're discovering just about general interactive techniques, like how to get people engaged, how to sort of upload attending, but you're also looking at machine learning. I'm curious how you're separating this is something that's sort of specific to the topic, like this is a good way to help people understand this concept or these things in machine learning, versus this is the principle of interactivity that we are sort of like zeroing in on.
Yeah, so the question is kind of what we're doing to sort of balance the interactive elements and the machine learning objectives.
Keep those 2 things straight.
Keep them straight how?
Well, for instance, like, is this a finding that is unique to understanding K values? Or is it sort of just a principle of, you just shouldn't have text everywhere if you do only 3?
Yeah, that's a good question. So I think the best way that we found to approach this was having more than 1 prototype so that we could use the same K-means in each one of them. And then the conclusions that we were drawing globally across 2 very different prototypes or 3 very different prototypes, because we've had additional paper prototyping as well. Those conclusions they would hold, if they held true for more than a certain number of prototypes, we felt like we could say with a rough accuracy that those are probably true of K-means as a whole, or at least the way that we were thinking of K-means as a whole, versus something that was just interactivity based, because there were such different kinds of interactions that hopefully it wouldn't be a lurking variable in just the way that we pick different interactions also.
Time for one more.
Yes, Mike.
You're adding extra difficulty by doing music or info viz where you're seeing it. Why finish with that extra difficulty?
Yeah, so I think, so the question was why we're adding the difficulty of music visualization, which is a difficulty in itself. So that was kind of one of our curiosities. We wanted to know what it would be like to visualize music. Currently, if you wanted to look at music visually, this was actually the prompt that we used to start it. You just have to look at the waveform, pretty much. And you're looking at an amplitude of music, and it doesn't really mean anything to anyone. It's sort of like a fingerprint of music, but it's not recognizable as, oh, this is probably a rock song. You could never know that just by looking at the visualizer. But we wanted to kind of see if there was something more valuable in 3D that we could use, like high parts and low parts and mid-tones, and see if we could render that visually in music as a way of kind of testing ourselves to see if we could visualize something usefully.
Yeah, also according to the user test from Sprint 1, like people are more willing to see the non-traditional data. Also, they want to see something in AR, VR. So that's also another reason that's why we choose music as our second sprint. Yeah.
Yeah, so while we were looking at like non-traditional data, we thought about music can be the one that's interesting to explore, and it can also work really well in XR platforms. So that's why we picked music.
Hi everyone, we are Team Train again.
I'm Leslie, the producer of the team. I'm Rohit. I'm the co-producer and the game designer.
I'm Sherry. I'm the UI UX designer.
I'm Hui. I'm also the UI UX designer.
I'm Chengguo. I'm the programmer of the team. I'm Abhi, and I'm the 3D artist and the technical artist on the team.
And Mo is our instructor of the semester. Our client is Phil. He's the ETC alumni and also the project manager of the Boys and Girls Clubs of Western Pennsylvania. And our stakeholders are Pat and Christine. Pat is the assistant teaching professor in the computer science and machine learning department in Carnegie Mellon University. And Christine is the director of STEM education of Boys and Girls Club. Our goal is to help the 14 to 16-year-old students to understand the concept of neural networks through interactive visualization of self-driving cars. And in order to reach our goal, we have 3 key criteria. The first one is that because our concept is really difficult for the students to understand, so we have to explain this concept clearly and accurately. The second is that we have to meet the client requirements. The third is we have to do plenty of playtesting and also do the innovation. Next, I will hand to Leslie to talk about how we start our project.
Thank you, Sherry. So, as Sherry mentioned, making such a technical project related to neural networks is really hard for us. So how did we start? First, we identified the main problem in this IAPI course provided by our clients. So the problem is it's very difficult to convey the complex AI concepts to high school students. So to tackle that, we first were thinking about making a collection of mini games for each of the modules, for some of the modules in the IPR course. And we proposed 8 ideas and evaluated them according to the difficulty for our team to make the games and also the difficulty for students to understand the concepts through the games. And then our clients give us feedback on how valuable they thought this idea would be. And later on, they gave us the 3 most valuable concepts for us to work on. And after the discussion with our clients and within our team, we decided to focus only on one concept, which is neural networks, and use self-driving car as a visual output of it. So after our students spent about 22 hours in learning the basic concepts of machine learning and artificial intelligence, we intervened the AIPI course by introducing the neural networks with a more interactive approach. And later on, the students will continue their learning with the more advanced knowledge. So we got a lot of valuable feedback from Carter. One of the most important question is that what is the role of our player? Are they just playing as an AI, or are they watching the AI perform actions? So we were thinking that by putting our students in the shoes of AI, they can learn AI better and know the AI processing and training process. So we decided that our players are playing as an AI. So now I'll hand to Rohit to talk about the work we've done after quarter.
Hello. So now with that, we had a focus about neural networks. Talking about the design phase and brainstorming. So we faced multiple challenges. So talking about a few of the challenges, first was visualizing neural networks. So neural networks are very mechanical and could be overwhelming to look at. So one of the challenges we faced was how to make it easier for the students to visualize and understand. Second was simplifying the concept for the students. So neural networks could be, like I mentioned, could be really complex to understand when you look at it. So we're trying to form a starting base so that they could understand the concept from a simple network and then make it more complex. So while I talk about making it simpler, we also want to reinforce the fact that neural networks in actually are very complex. And even though we are explaining certain things, simplifying it, it's part of a bigger picture. And lastly, thinking about flexible design. So students coming from lectures to our game, we want to make it we want to keep the starting point same for all the students, depending on what knowledge they had from the lectures. So let's look at what our game structure is going to be like. So we have divided it into sections. The first one is the introduction. This is basically the onboarding part where the students just brush up on the concepts that they have already learned in the lectures and sort of revise the concepts for them and forms like a good starting base. And then we have level 0, which talks about vocabulary related to neural networks and everything associated with that. And we also introduce linear regression, which forms the base of a neural network. After which we have level 1, which introduces perceptron. Perceptron is basically the simplest form of a neural network. So we expect students to solve certain scenarios using the model. And lastly, in level 2, we have a more complicated network, which is multi-level perceptron. So in the game, we want to take a step back and just talk about what a neural network is, the general idea of it. So it could be thought of as something similar to a human brain, which collects data and recognizes patterns and tries to solve problems. So just like a general idea before we get into the structure of the neural network. And then we talk about, like I mentioned earlier, it could be really overwhelming to look at the structure because it's really complicated. So so first is the input layer, which consists of multiple inputs. This is where the data flows into the neural network. And then we have the output layer, which also has multiple outputs depending on the complexity of the structure. And then we have the hidden layer, which has different functions like inside the nodes. And this layer is used to solve further more complicated problems. These different layers are connected to each other, and this forms the network. So as you can see, it's very overwhelming to look at, and I don't, as a student, might not understand what's exactly going on. So I would like to call upon Abhi to talk about how we're going to simplify the structure and what vocabulary terms are we going to introduce related to neural network.
Thank you, Rohit. So as Rohit mentioned that we couldn't let the students directly jump into this complicated structure, so we wanted to simplify it a bit first. So so first we get rid of the hidden layer, and then we reduce the number of inputs and the outputs to just one each. And as Rohit mentioned, that these are all connected. So these are connected using something that's called a weight. And weight is just a number that dictates the influence of the input on the output. And the AI actually adjusts this weight during its learning process. So as Leslie mentioned, that we want to put the players in the shoes of the AI. So this is where we're going to give the control to the students. We're going to let the students control the weights so that they can actually see how the input is affecting the output. And then there's another term called the bias, which is simply a constant. So now when you combine all of this, the equation of a straight line pops up. And this is what forms the basis of all neural networks. So this is where, this structure was still a bit too mathematical and computational for the students to understand, we felt. So we wanted to add another layer of abstraction to it so that it could be, better for the students to understand. And this is how we're going to map it to a more playful UI. And so basically what we're trying to do is introduce a concept of a hypothetical juice called a neural juice. And the students are going to use this neural juice to control a self-driving car. And adding this layer of physicality to an abstract mathematical concept we think, would be helpful to the students. So here you can see that the neural juice is going to be analogous to the data that's flowing through the system. The amount of juice is going to be analogous to the magnitude of the weight. And the color of the juice is going to be analogous to the sign. So how do they control the car with that? So from the output, so whatever color neural juice is going to be in the output, that's going to dictate if the car goes or stops based on certain scenarios. So if the juice is green, the car goes. If the juice is red, the car stops. So that was level 0. And coming out of level 0, this is the structure that the students are going to be familiar with. So now we want to increase complexity gradually. So we add another input to it. So this is going to help the students understand how multiple weights are going to influence the output now. And again, this is going to be a similar mapping to another structure, which is kind of similar to what the students saw in level 0. And here, the inputs are going to be a green light sensor and a pedestrian sensor. So the first sensor goes on when the car detects a green light, and the second sensor goes on when the car detects a pedestrian in front of it. Now I would like to call upon Hue to discuss more about the UI UX choices that we made.
Thank you, Abby. So we designed the neural networks of the self-driving car on the left and the scenario on the right. As Leslie mentioned before, the player is playing the game as the AI of the self-driving car. So they need to discern the the road conditions on the right first, and then adjust the weight to get the right output on the left. So these two are the sensor input of the self-driving car. One is a green light sensor, one is a pedestrian sensor. So when the car senses the green light, this sensor will light up, and the neural juice will go into the PEP. The same thing happened here. When the car senses the pedestrian, it will light up. So the player can move the valve up and down to control the importance of the sensor. So the more liquid means the more importance of the sensor. And when the neural juice passes through the negative sign, it will bring the negative signals. For now, the mixing container is empty. But when the player clicks the run, the neural juice will go through the mixing container. So when all the neural juice in the mixing container is negative signal, the car will stop. When all the positive signal, the car will go. And we're also considering many scenarios here. So when the green light and the pedestrian appears together, what will happen? It means the positive signal and negative signal will appear in the mixing container at the same time. So we design the one negative signal and one positive signal will cancel each other out at here. It means when the negative signal is supplied to the positive signal, the output will be stop. So here is the 3D art of what Abby made. In order to better integrate with the UI part, and considering our game platform is WebGL, which needs the low poly, and our target audience is 14 to 16 years old students, we decided to use a voxel art style. So next, Simon will talk about our tech part.
Okay, thank you, Hui. For the tech part, we plan to use WebGL plus Unity for our platform. The reason we do this is first, every AIPS student will receive a Chromebook for their courses, and all their existing materials are web-based, which will make them feel natural. Second, web-based allows us to maintain our projects easily. And this is our prototype for the tutorial part. People will click next to get the instructions to help them get on board. And this is the prototype of level 1. And you can see on the top right is this traffic scene. And in this thing, there's a green light so that we have to adjust the ways to make the neural juice to become green and then click run. And we have conducted playtests recently and collect many valuable feedbacks. And the most two frequent of them is, first, it's hard for playtesters playtesters tend to click the go button other than run button. And the second, playtester feel it hard to connect the scenario in the traffic scene with the node inputs. And this will be the things we will deal with in the future. And we'll try to use this by making better UI arrangements or animation. Now I will hand over to Leslie.
Thank you, Simon. So after half, we're going to spend 1 more week on the intro and level 0, and 2 more weeks on the level 2 development. And later on, we'll spend 2 more weeks on the polishment and prepare for the soft opening. And the final 2 weeks, we'll prepare for the documentation and final presentations. So we are team trained again, and now we're open for questions. Thank you. Yeah. Yes, Dave.
Are you getting feedback from the students in the class and I guess the teacher as well, and how this is fitting in with what you want, what the classroom wants?
Yeah, so the question is, are we receiving the feedback from the IPS students and the teachers? And the answer is, we haven't done that yet, but we are planning to do that after the half, because the IPS students have to spend like about 22 hours in the formal AIPR courses, like the module 1 to 9, as I mentioned in the presentation. So the client part are not as ready before the half, and we'll do that later on. Yeah, thank you for your question. Any other questions? Yes, Mike.
So in your example, it seems that the color really matters, the go, no-go, the binary choice of red or green. I'm not sure about the weight, the amount, and how are you going to explain that? How is that going to also matter, the volume of juice coming through?
Thank you, Mike. Sorry. So the question was, how is the magnitude of the weight going to matter along with the sign of stop and go? So the way it works is, so for one of the cases that we showed was that the green light sensor is on along with the pedestrian sensor. So in that case, the green light sensor tells the car to go, and the red light sensor tells the car to stop. The pedestrian sensor tells the car to stop. So in that case, the students have to figure out that even though there's a green light, but the magnitude of the negative juice flowing should be more than the magnitude of the positive juice, so that we can have a surplus of negative juice, which at the end, after the mixing, dictates that the car has to stop.
All right, thanks, team.
Thank you.
Hello, everyone. We're Team Blue Farmers, and in this semester, we're going to deliver an AR educational project. First, about our team. Our team is consisting of 4 people. I'm Chi-Wen. I'm the producer and 2D and 3D artist. Jialu is our programmer, and Shi-Wen is our UI and UX designer, and Tili is our UX researcher, and our instructor is John. At our quarter, we are focusing on off-site AR experience, but right now we changed our target to our client's facility on-site tour. First, about our clients. Our clients is Bluestream Farms. It is a West Virginia nonprofit entity. They provide some on-site tour about teaching students the knowledge about aquaponics system. And other than the aquaponics system, they also provide hydroponics and microgreens. So what is aquaponics system? Aquaponics system is basically a system that uses fish waste to become the nutrient for the plants. And after getting absorbed by the plants, the water will be purified and came back to the fish tank. And about our projects, we're going to focus on the high school students who are paying on-site visit to our client's facility. And our clients want us to teach the students some knowledge about aquaponics system, and also spark their interest to learn more about the system. Based on our client's need, we came up with some concept. We're going to make a really playful experience with a lot of intuitive interaction so that people can learn the knowledge of aquaponics system without knowing.
Okay, here's our user research. We did basically, we did some desk research and first-hand research to help us to better understand our target audience, high school students, and stakeholders. And for the desk research, we found that almost all the high school students, they own their own mobile phone. So that's a big opportunity for us to build a mobile app for the high school student. And we also come across a lot of studies, and they definitely show that AR can definitely enhance the academic performance of high school students. And then we go to the Bluestream Farms, and we go around their facilities and we found that that's a really interesting experience. But even we are on site, we cannot see the things, see the bacteria in the macro world. And as we mentioned that the high school students, the most exciting part is about the fish, but the water in the water tank is very muddy. They cannot see the fish, even you get very closer to the fish tank. So that's a key insight we found from the on-site visit. And this is a layout of their space. And also we conduct a lot of interviews with high school students and their teachers. We found that their current teaching process is like that. And we think that we could replace the stage. They assemble a system and observation, because actually in the Blue Stream Farm, they cannot suppose students to assemble the system right now. And also it will be harder for the high school student to just observe the facilities than having some interaction with the facilities. And here is our personas. Our target audience is a high school student, which is very interested in pursuing some very interesting and cool experience out of the textbooks, and also they're very interested in entering some extracurricular activities. And to summarize our current user journey, we prioritize three most painful points. The first one is how to help students to entering the interaction very naturally and intuitively. And the third one is actually how could we make it easier for the high student to absorb the knowledge behind the aquaponics system. And the third one is how could we visualize the macro mechanisms by the eyes.
So next, I'm going to introduce about some related works. First is about related ETC projects. We took a look about ETC projects and we found these three are most helpful. Especially for Wanda Math, they use AR Foundation so that they can finally deliver their product both to Google Play and Apple Store. And we want our product to be accessible by most people. And we also found there are a lot of interesting interactions with chemical formulas and also the marker-based AR technology really inspiring in the other two projects. Besides, we also research about the latest AR technology. Take the example of the Apple Reality Kit 2. You can see this really wonderful visual performance of the underwater demo. However, they are strongly restricted to iOS development. We want our product to be accessible, so we choose to use AR Foundation as our platform, and so that we can finally deliver both on Android and iOS devices.
So based on all our research, no matter the DEX research or user research, we have our solutions. We want to use our design to answer that question. How might we utilize the AR technology to visualize the macro world behind the knowledge to the high school student? And we bring a lot of ideas, and then we choose these ideas. We want to tell the story of fish food. Mainly basically you as a player, you will just have some onboarding parts, and you will be eaten by the fish, and you will go through the filters and eaten by the green root, and then you will have your own customized plants. And in each stage, we will have 3 levels. The first one is onboarding, and second one is mini game, and then you will offboarding with some knowledge. And because we are an on-site experience, so we create a tour for our audience. We want to use our application to get the audience to go through the facilities to better understand the real-world facilities and with the AR stuff overlapping it.
So now let's talk about what we have so far. As Tilly mentioned, our experience will consist of 3 parts, 3 chapters. The first chapter will be about the fish tank. Another chapter will be about a filter, and the last will be about plant growing value for the plant. So let's take a look at our prototype. So for our experience, there will be a sticker sticked on their facility. So for the first chapter, it will be about the fish tank. So high school students need to find that stickers on the fish tank and scan that stickers. And then there will be a portal show up with some fish swimming inside, and then the students need to approach that portal in order to get into that portal, which is an underwater world. So at the very beginning, we'll let the students know that you are currently a fish food, and you are trying to be eaten by the fish. So there will be some fish swimming by, and you need to approach that fish in order to get eaten by it. So when you approach it, the fish will come to you and try to eat you. You actually need to do it 3 times as indicated on the top left corner. So after you got successfully eaten by the fish, now you are turned into a fish poop. And after that, we're gonna have a knowledge section where we'll tell you the science behind everything, and we'll also show video clips of our Blue Stream Farms online courses. And when the students are ready, they can start the next adventure, which is actually about the filter. So still the same thing, you need to find the stickers on the filter, scan that filter, and then there will be a bacteria world you need to enter. So as we mentioned, like last time you turn into poop and start with the poop. And this time you need to go through the hose of the filter. So, and then the next phase, as you go through the hose, you will be like filtered by this foam, as for sure. And then for the next stage, there will be some bacteria inside that hose. So you need to go through that hose, collect that bacteria in order to have some chemical reaction with it. And as well, you need to do it 3 times as indicated on the top left corner. And now this time, you are turned into a nutrient. Of course, there will be some knowledge section telling you the science behind everything. And the last chapter will be about the growing bed. So you need to find the stickers on the growing bed. And this time, you are entering the world full of plant roots. So you start as a nutrient this time, and need to approach that root in order to get absorbed. So when you get absorbed, there's some color change or some indication of absorption. You need to do that 3 times as well. And this time, you are now turned into a plant. And there will be some knowledge about like the science behind everything. And finally, we're going to show you what kind of plants you got turned into. So this time, you turn into a basil, and there will be some information about basil as well. And you are able to share this whole screen with family members or your peers so that other people can enjoy this same experience by scanning this QR code.
And here is our 2D and 3D art style. We are trying to make it look colorful so that we can spark students' interest to learn more about the knowledge about aquaponics system.
So here are our currently tech demo and iterations. The first video here showing that you are going. Yeah, you can see the video playing now. You're scanning a sticker on the fish tank. We take this half sheet as an example. You can see the fish swimming inside, and you're trying to approach it so that you can dive inside. Now you are inside the fish tank. The first stage, you're going to find an empty space for safety. So now you are playing as a fish food, trying to get swallowed by the fish. So we decided at first, you just need to be consumed for 1 time, and we, after playtest, find out that people may get confused when everything's happening too fast. So now we can see that you need to be consumed for 3 times, each from different fish. So now you are consumed by the blue tilapia, and you're turning into the fish poop. So next is about our second demo of our second chapter. You are in the filter chapter. Similarly, you scan the sticker and come inside. You're playing as a fish poop now. And you're trying to get through the filter. The water will get cleaned up when you successfully get through the filter. And you will get smaller and smaller. So at first, we don't have this fish poop indicator in the center of the screen. Player could get frustrated when they can't get through the filter and they don't know what size they are. So we add this indicator for a better game experience.
And for our future plan, we see the playtesting as a really important of our iteration. So we're going to have ideally on-site playtest. We are going to go to our client's facility and invite high school students to do the playtest right there. And we're thinking to do it bi-weekly. And for a substitute plan, we're going to invite students from the main campus or from ETC to have the playtest in our project room. And to make it look more like an inside experience, we will try to use some cardboard or colorful image to mimic the system that is right now in our client's facility. And there are 3 potential risks and challenges we can think right now. First is, since we are a delivery project, we're going to test it more often on site so that when we deliver to our clients, there is no bugs. And second, we will provide some really detailed instructions, so when we hand it off to them, it can make the whole process more smoothly. And second is about the how are we going to measure the success? First, so we are going to create a survey question list to the high school students before and after they experience our application to test if they really learn some knowledge about aquaponics system. And the third one is that our stretch goal is to make our experience also happen offsite. To make this come true, we are going to generalize our experience. So when our clients have more location-based, they can easily put our stickers on their new system and to make this work. And also we're going to add stickers to their website so that more people can get access to it through scanning the stickers on their website. So in the end of the semester, we're going to make sure that we achieve all the client's requirements with a high quality application, which include a lot of interesting interaction. So in summary, in the end of the semester, we're going to build an AR experience that help high school students better absorb the aquaponics system knowledge during their Blue Stream Farm on-site tour. And we're open for questions and feedbacks. Thank you. Yes.
So you're building an AR experience, and some of it for the user will mimic being underwater.
Yes.
It was an odd moment for me when I looked at the screen and saw the bits of poop floating against the background of the furniture in your project room or whatever.
Mm-hmm.
Are you concerned that that problem of the figure-ground relationship between what you're saying the user experiences, I am underwater, and the requirement in AR that the room itself be there will be a detriment to your final experience?
One of the
Yeah, I think that's a really good question, and we will test with our high school students to see if that's really a concern for them. So we hope our experience is interesting enough for them to ignore the actual background, which is not very like not the real underwater stuff that's supposed to be there. So I think we will see if our experience is interesting enough for them to ignore the reality background there.
And the other reason we want to make it look like this is because there are going to have 10 people at the same time experience our projects in their facility. We're trying to make sure that they do not hurt each other because if they're in a VR world, it will be easy, they maybe hurt other people when they collide to the system.
And another thing is, for our experience, you can start our experience anywhere in this facility. So if they think they found the furniture or stuff in the side around the system is really annoying, they can find an empty space. I think our client has a pretty big room, and then they can find an empty space to start our experience. Yeah.
I may have missed this, but you may have said this. Are they using iPads, or are they all using their own phones?
They're using their phones.
Yes, Mo?
It's an interesting choice to, for example, to play as food rather than to feed the fish or eat. The bird becomes to be eaten or to be sheltered. Yeah. And this might create a disconnect in the user. Can you talk about that choice and why you might?
Yeah. Yeah, because like at the very beginning, I think our client mentioned an idea of like want the students to be like a water or water flow to experience the whole system. So we think it might be nice if the students can experience the whole flow in the first person's perspective, and that's why we choose like these students to play as the fish food, to experience everything themselves. So that's the reason. Instead of like being observer, like being the maintainer of the system, they feed the food, they feed the fish the food, and then they maintain the system. I think that's another perspective. So we just want to make the experience more immersive and so that they can experience in their own in the first person perspective.
Yeah, to add on, because we know that it will be harder for the high school student maybe at the perspective of the fish food, so we will create a very contextual onboarding part to help them understand where they are with their fish food, something like that. And also we will conduct some playing tests to identify that is there some challenge for them to understand.
The tour is happening, this is part of the tour, right? I'm just kind of curious how this fits in with the tour. Does the tour guide say, okay, you got your phones and go play this game? Like, I didn't get a good sense of the integration of the sort of individual AR experience and the tour together.
So yeah, I think primarily we designed this way. Like students will first scan stickers, start our experience. And after that, for example, after the first chapter, the fish tank, then the tour guide will explain, further, have some further explanation or answer any question they may have. And after that, tour guide say, okay, next, let's scan the next chapter, and they will do that things. So that's the first experience that we designed. Another thing could happen is they could experience all the games. There are two floors on the client's facility, and the second floor is about learning. So it could be like they are learning some concept, and then like the tour guide will say, okay, let's go downstairs, experience that in AR, and then go downstairs to experience it. So we design it in two ways, and it's up to the client to choose which method they think is more fit for our education purpose.
Hi, good morning, everyone. Thank you so much for being here. We are Team Sparks, and in the next 15 minutes, we are going to share our project progress so far. Before we get started, I would like to briefly introduce our team. We are Team Sparks, and we have Yukti, Ash, Peter, Jerry, and also myself, Valerie. Our instructor is Brenda Hager, and our client is Samira Kiani, who is the associate professor of University of Pittsburgh, School of Medicine. She is also an expert in the gene editing. After we have a discussion with our client Samira, we learn about her needs and expectations. She wants an experience that can be repeated, connect scientists to the public, and at the same time attract a public attention to science. The experience also should allow the public to have conversations with scientists. So now I will pass to Yukti to talk about our project.
Thank you. Thank you, Valerie. So essentially, our goal was to create an experience that would help bridge the gap between scientists and the lay public, because both of these are very important stakeholders in humanity's collective future, and it's important for them to have conversations about the direction science is going in. We also wanted to present both sides of the debate regarding the very controversial topics of gene editing and CRISPR. So therefore, our solution was to propose an interactive virtual museum where the videos and the players could experience videos and mini games where the content would be provided by the scientists. And in order for us to reach the largest possible audience, we chose our platform to be for our experience as WebGL. I will now call upon Jerry to speak to demonstrate our prototype in front of the audience in greater detail.
Thanks, Yuki. Yeah, so this is the demo of one of our so-called department. It's a main place for us to show content to the users. And as you can see, there's a customization panel where users can change the model and color of their avatars. And also there's a message board for you to leave messages. So the department will be filled with show boards carrying posters, quotes, and web pages. And they will respond to characters' movement to make them feel that everything's interactable. And there's also some mini games. For example, this one's a puzzle game. So for each of this game, if you succeed, you collect a stamp for achievement. Yeah, and there's also some video screen. So if you stand inside this circle, the video will play automatically. And if you leave, the video stops. And we also make some 3D icons for functions like message board and customization to make it even more immersive. And that's pretty much everything we've got for now. Peter will talk about the experience design in more details.
Thanks, Jerry. So now I'll talk about the design. So before the quarters, our main focus was to help promote the project Tomorrow Life. And it kind of soon became a marketing problem for us. And we're really not a marketing team. And based on the feedbacks we got from the quarters, we quickly shifted our focus to create an interactive experience that is using technology that can spur the conversation between the general public and scientists. We noticed that some big tech companies such as Apple and Microsoft are doing this amazing stuff that can promote their stuff in the and store it in the form of interactive world experiences, WebGL experiences. It really caught our attention as it is something that we haven't seen a lot in the past. The user gets to play as a character and interact with stuff and information inside a huge open space. It's almost like a virtual theme park. And it combines art and technology perfectly to tell the story of their products in a super immersive way. It essentially became our main source of inspiration for the experience. And we think we can do it too, and even better at some perspectives. We also went to the Carnegie Science Center to learn from the physical experiences. And one thing we noticed is that there are a lot of animated stuff inside the Science Center, whether it's interactive or not. Guests are constantly drawn from one thing to another. These fun and nice to watch experiences in the museum are the reasons guests are constantly engaged, and they are very effective at conveying information, knowledge, and stories to the guest. So we want to kind of have that same kind of similar experiences in our virtual theme park as well. In conclusion, we want to create a virtual science theme park about CRISPR, genetic editing, and we want to provide attractions, departments, all those kind of hidden surprises and wow moments to the guest, and spread information, knowledge to the guest. In the end, we want to promote communication between the general public and the scientists. And this is kind of what we found online for the inspiration of the look for our theme park. We want to create a kind of cozy and welcoming environment so the guests can spend more time enjoying the experiences. And this is the map layout. Starting from the entrance floor, guests are prompted with introduction of the experiences, including project name, logo, etc. Next, guests can take the elevator to the first floor. This is where the actual experience starts. User can freely roam the beautiful dome-shaped area we created, take elevator to different levels, visit our departments, and there will also be all kinds of mini interactions spreading around the space so the user don't get bored. And next, I'll pass it to Ash to talk about the target audience.
Thank you, Peter. So our target audience would be young people that age between 18 to 29. According to our research, this is the group of people who surf the internet the most and likely to accept new things. What's more important is they are the group of people who shape our future. So it is important to make sure that they're well educated. So we'll make this kind of interaction and engaging experience for them. Some personas can be college students, web developers, social influence, but there could be more. So next, I'll pass to Jerry to talk about the technology.
Thanks, Ash. So we're building a web-based experience using Unity, and are mainly targeting at PC users. And we're also implementing multiplayer functions after the Halves. So we chose to use WebGL because we think it is most easy to access and share on social media, as well as it has a strong and efficient support for complex visual effects. So for this semester, our focus will be refining the experience itself, and that's why we limit the platform to only PCs. But with WebGL, it is easy to port to other devices and platforms for future development. And the reason we're adding multiplayer elements and making the whole thing online is that we think if the users feel they're not alone exploring this world, they're less likely to get bored. So we're allowing them to send emojis to communicate with each other, and also we'll fill up the plaza with fun mini interactions to make it a joyful place for even just hanging around. And after the Halves, we will build up the server and implement login and register function. The reason we're doing that is we want the users to be able to leave messages on the message board of each department and also to receive responses in their inboxes. The responses could be coming from other users or scientists and experts, and that's where the conversation really happened. So with that being said, we're actually calling our users to come back to this world repeatedly instead of making this whole thing a one-time experience. So I'll pass on to Yuki and Ash to talk about some smart design.
Thank you, Jerry. So I would like to speak to the key concepts that inform the visual style of our experience. We wanted this experience to feel as immersive and futuristic as possible, and therefore these were the keywords that inform the art style and visual choices that we made for the concept art. This theme was continued into the character design. This character is something that the player will use to explore our experience. It was very important for this character to not be visually distracting from the rich environment and interactions all around the player in our experience. However, we also wanted to afford some degree of character customization. So at the present moment, for this particular character, the color of the lights appearing on this robot can be changed. And also, the display panel on its chest can be customized to display different symbols which correspond to the 4 important genetic components. It can be changed between A, T, G, and C. This theme of gene editing and CRISPR also informed the architectural style that we used for the departments. The building that you see here is the department that houses information about CRISPR. Its double helical structure is a direct visual callback to that of the DNA strands themselves. I will now call upon Ash to talk a little bit about the user interface design.
So for our design of the interface, we choose the color palette that consists of blue and different shades of green. Blue represents the color of gene and biotechnology, while green represents nature. And it also gives people a welcoming feeling instead of pushing our user away. We also made it work on both light and dark backgrounds. As for typography, we choose sans serif font to make it look modern and futuristic. We also made some icons and buttons based on the color palette. This is the main interface during the experience. There are 3 buttons on the top and 1 on the bottom. So the first icon is avatar settings. In here, the user can customize the texture and also color of his avatar. The second one is the message board. Each department has a message board. The user can leave a message here if he is interested in this topic or have a question or comments. The message here can be replied by any users in the experience, including the scientist and other guests. And once other replies your message, his message will show in the inbox page. And in here, you can have a conversation with the scientist or any other guests. The emoji buttons allows user to express themselves instantly. So once he chooses emoji, the emoji will appear on his avatar so other people can see it and reply it. We also made interfaces for mini games. For example, here is the sliding tile game. Once the user complete the game, he will get a stamp. And actually, every mini game has a special stamp for users to collect. By doing this, we encourage them to explore our world as much as possible. As for the lighting, we spend a lot of time to mimic the nature environment. As you can see, we use light blue environment here to show the technology feeling and bio feeling, but we also make it welcoming for our users to not pushing them away. So here we implement emissive lighting to the still images and videos and look at the floor reflection. So it is look realistic enough to make people feel they're in a very real environment. So next I'll pass to Valerie to talk about our roadmap.
Thank you, Ash. So after talking about the job we have done, I want to talk about next steps. So here is our future plans. We are now in week 7, and we have already done a full functioning department with different interactions. So after the spring break, which is week 8, we are gonna start our playtest and keep developing the 2 other departments and Plaza. So in week 9, we plan to finish the other 2 departments, and after that, our whole virtual theme park should be done and allow us to do the final playtest by week 10. So depends on the playtest and the feedback from week 10, we will do the final polish and wrap up in week 11 and deliver it by the end of week 12. Playtest is a really significant part, and we plan to focus on 4 aspects in the final playtest. For the engagement, we will try to observe if the players are willing to walk around in our virtual theme park and enjoy the experiences. For the knowledge, other players learn something from our experiences. And for the interaction, other players are easy and freedom to interact with different things in our experiences. And the last one is conversation. Other players feel easy and convenient to have conversations with each other and also the scientists. So this is basically all our future plans, and I will go back to our project. So we are going to create a product, and this product will be an interactive genetic virtual theme park. And this virtual theme park allows scientists and players to connect with each other and also have conversations. And all the content in our virtual theme park should be customized and edited by the scientists, such as our client Samira. So our vision is educate, inform, and engage. And that concludes all our presentations. Thank you so much for listening, and we are now open for questions. So your question is how many interactions in our showroom, right? Basically now we have mini games and video trailer, and also you can click on the pictures and there will be an article on there, and people can look some articles and gain some knowledge from there. Right. Sorry, please.
So a lot of your engagement relies on scientists interacting with the participants. How do you incentivize very busy professional scientists to come and communicate with the participants?
So we had a conversation with our clients who are scientists, a team of scientists themselves regarding this concern. And what was shared with us is that the main motivation for scientists to share their stories is if they feel like there's a receptive audience for it. And the second factor being what is the ease of pushing content from their end to a platform where it can reach the largest number of people. So after a discussion with our client, it was explained to us that if these two factors could be taken care of, that we provide them a way to interact with users and also make sure they reach a larger possible audience, then scientists were more and more motivated to share their stories. And contrast to the previous project, Tomorrow Life, where the main issue was that as the reach did not match their expectations, this reduced their motivation to come forward and create more content. Yes?
Okay, sorry. So if I put on my targeted marketing hat, there's folks who trust doctors and science, and then there's folks who will never trust science, and there's probably some sort of middle ground. Have you looked into that demographic and the problems that might face with that?
Yes, we have. The question is, there are people who trust the scientists and there are not. Yes, we actually thought about this question. So we are considering to make two completely different departments. One is talking about the positive side of the science, which is genetic editing, CRISPR, and one is the bad side of CRISPR. So during our experience, our user can experience a good and bad side of our topic, and by doing this, we can be more general and inclusive, if that answers your question. Yes.
Yes.
It sounds like the platform, part of the success would be the number of people who are on it and using it. I'm kind of curious, what are your goals for that? Like, do you have a number that you talk with the client about? Like, you want to have this many active participants, you want to have this many current users? What is your metric of success there?
So your question is the number of the target audience, right? Like how many people will come to our virtual park? So actually, this is a marketing question. And before the quarters, we also think about how many numbers we should bring to this theme park. But after we have discussion with Samira, we try to focus on our experience on the theme park itself. So we provide a platform this platform will edit by the scientist. So that's and we also bring the multiplayer to this virtual theme park. So we think that the users are not the priority question we need to think about. We just provide a platform that welcome as many as guests we can. Thank you so much.
All right, that's time.
Thank you.
Check mic 1, 2.
Hello everyone, my name is Minken, and we are Team Hermes. So just to introduce, we have Lena and Yiming being our programmers, and we have Tanvi our technical artists. Shanshan and Tao is our designer, and Nolan and myself are mainly producing. And our faculty advisors are Tom and Shirley. And we have our awesome client, Stefan Kasper, who is a CMU professor, and we are creating immersive experience for him in the Global Language and Culture Room, which we'll later refer to as the GLC room. So just a one-line summary for our project. Team Hermes is creating a cooperative, asymmetric experience about environmental challenges in Amazon using both VR and wall projection technology. So our main goals are to support the already existed collections of experiences in the GLC room, to create a human-centric experience, and to raise awareness and create conversation about multiculturalism. Next, I'll introduce Nolan to talk about experience design.
Thank you, Minkan. And hello, everyone. For our experience, we would like to discuss the Amazon River and how it is a home to various indigenous tribes within the Amazon. Moreover, we would like to talk about environmental challenges facing the Amazon and these indigenous tribes, such as deforestation and pollution. Our experience will take place within the Immersion room within the Global Language and Culture room, which features an HTC Vive head-mount display and 3-wall projection. In the Global Language and Culture room, there are several experiences. These experiences last around approximately 5 to 7 minutes. And in discussion with our client and the detail we would like to successfully achieve in our experience, we would like to approximate a 7 to 10 minute experience. There we go. Our target audience is college students because the Global Language and Culture room is often used by classes on CMU campus to enhance their curriculum and classroom discussions. So they'll go there, put their kids through the experience, and have discussions afterwards. And we hope to achieve a longer discussion about the Amazon after our experience. And what really interested our client in discussion with him about the design is this idea of cooperation and asymmetry. For the cooperation side, our experience will use 2 guests, but it can support up to 4. And my apologies. The asymmetrical side will feature unique visuals and interactions for each guest. Which leads us to our story. Our story centers around an NGO that is traveling through the Amazon River to film a documentary that will change policy in the hopes that they can change policy and practices in regards to deforestation and pollution. This NGO will use 2 agents to conduct this documentary. A field agent, which will be the VR guest, and their goal is to travel down the Amazon River via boat to record footage and audio for this documentary. And meanwhile, they will have to communicate with the research agent, which will be the immersion room guest. And the immersion room guest will have 3 walls projected to them filled with information that they can use to communicate to the field agent or VR guest. And this comes back around to this idea of cooperation and asymmetry in our experience. And so by making a documentary, we hope that the guests will be able to learn and discuss more about deforestation and pollution after leaving our experience. And we play tested this idea a couple weeks back via a prototype. On screen now, you can see 2 visuals that were from this PowerPoint prototype. Each were unique to 2 individuals within the playtest. We play tested it with several ETC students, and we got several pieces of feedback in regards to general interest in the idea, the communication aspect to it, and overall narrative. And now I would like to hand it over to Tao to talk about mechanics.
Thank you, Nolan. I'll be talking about the mechanics of the game. As Nolan mentioned, our game will be a cooperative and asymmetric experience, which means that the VR player and the immersion room player will have different views. So for the VR player, as he's playing as the field agent, there will be 2 main mechanisms. The first is rowing, and the second will be filming. Talking about rowing. Rowing will be the main mechanism how the VR player is traveling through the map. With the HTC Vive, we're designing this mechanic where the VR player will be using the 2 controllers as the pedals and actually physically rowing to move along the map.
we think with this interaction, the experience will be more intuitive and more immersive. For the filming, the VR player will have a camera mechanism, and when the VR player is pointing the camera as the points of interest that we designed, a real-world footage will show up on the camera screen. By showing this real-world footage, we think with these real-world footage, we are better showing real-world problems. For the immersion room player, there will be a different set of interaction. The immersion room player playing as the research agent will be mainly interacting with the screen and providing information for the VR player. So he'll be able to open documents and also match the footage that the VR player sent through with the information in the document. As well, the third interaction for the immersion room player will be a map to track the VR player. Although the immersion room player will not be able to see exactly what the VR player is seeing, having a map will enable them to communicate with each other in a better way. And now I'll pass it to Shanshan to talk about the user interface.
Yeah, thanks, Tao. So next, I will talk about the user interface in the immersion room. Since our target audience is mainly focused on the students, so many of them are inexperienced with VR and immersion. So at this time, we're thinking usability is a key for us to design the interface. And this is what our immersion room looks like. So we're trying to design the 3 words interface to help them to play with another player. And also, this is a real picture we take from the immersion room perspective. And so to ensure the usability and the immersion of the interface, we come up with 3 key design elements. So this is the video, basically show the interaction of the interface. So in the video, we can see the player can use the swipe feature to doing some of the interactions. That's because we're trying to use the swipe feature to mimic the phone swipe interactions to make the player, they can quickly and easily to use it. And also, we're trying to use the priority of information to design the menu part so that the players can know the importance of the different level of information. And also, we're trying to use the visual design to improve the immersion environment so that the player can, which can make them feel like they are in the real environment. So next, I will pass to the Tevi, talk about the environment.
Thank you, Shanshan. So a huge part of our experience is immersing the virtual reality guest into the Amazon rainforest. So while designing the Amazon rainforest, there were a few points of consideration. One was the guest perspective, which is a first-person point of view of the guest traveling in the boat in the Amazon River. The second part was the different sites that the guest would be able to see. One would be a normal river view. Second would be a deforestation site. And third would be an inhabited land, or in our case, the settlements of the indigenous tribes. The journey of this was we started off with a highly accurate, procedurally modeled forest. But on testing this, it instantly dropped the entire performance of the game. And that was not what we were trying to achieve. Shifting to an extremely low poly modeled forest also did not satisfy our requirements because we wanted a sense of immersion. We finally pivoted to a more stylized but low poly version of the Amazon rainforest. This is a current screen capture of what you will see in the tech demo ahead. As you can see, it's low poly and more stylized, and we will be working on this further to incorporate the previously mentioned sites into this. I'll now pass it to Lena to talk about the tech in the project.
Thank you, Tanvi. So we have encountered several technical challenges. For example, the first one is the synchronization of different screens, because as you know, we got the immersion room with 3 walls with 3 projectors, plus there's a VR lens, so we have to synchronize 4 screens. And intuitively, we are going to implement a local network and to make the communication between these 2 platforms. But we used a smart alternative method, is to build one project with 2 scenes and use different displays to make them work at the same time. And this will even improve the smoothness between different platforms. And also there is a boat rowing mechanism, and it is hard to feeling you're really rowing a boat in VR, and because the user is currently using the controller. So we also implement this to make the player feel like really rowing a boat, and we made this work. And I'll pass to Yimin to introduce more details with tech demo.
Thank you, Lena. I will introduce the tech demo. We will show the VR player rowing in the world and interact with the interest point to trigger the video. And we also will show the immersion room player interact with the canvas. They will communicate to find information and to match the information with the right pairs. And let's see the video.
Where are you? Oh, there you go. I see you're rowing the boats to the corner. You probably want to change your direction. From the information I see, we first need to identify some pollution in the Amazon rainforest. It talks about an oil spot, an oil pollution spot. Oh, have you seen the red dot in front of you?
Yeah, I saw that. Oh, it was a radio.
Yes, it's
about pollution.
Video about pollution.
I think I will send the pollution video to you.
Oh, really?
You may get a
Oh
video
yeah,
later.
there you go.
Yeah.
I saw the video. That's the video. I think that match with the description here about the oil spillage.
Yeah.
Let's try to match them together. There you go. I think we found the first match of the documentation.
Cool.
That's awesome.
As you can see right now, the immersion room player used the mouse to do the input, but later we will try to use the wipe tracker to do the interaction with the screens. And the other thing is, right now we use 3D sims to simulate the screens in the immersion room, but later we will use the real projection. Next, I will let Minghan to do the timeline.
Thank you, Yimin. So our plan for the rest of the semester is, for the development phase, we mainly split it into two parts, the pollution parts and deforestation parts, which each will take around 2 weeks, and then we'll wrap up all the other features and from the previous iterations before week 13. And for the art side, environment art is a huge part of our game, and we'll try to finish it by week 10, and then we'll work on post-processing and shaders. For playtesting, because this is a location-based experience, so we're planning a 2-phase playtesting. The first phase, we're decorating our room to simulate the immersion room in the GLC room. And so we'll start, before week 11, we'll do the in-room playtesting. And after the physical installation in the GLC room, since week 11, we'll playtest in the GLC room. So special thanks to all of our playtesters, our faculties for your awesome feedbacks, subject matter experts. And just to summarize, we are Team Hermes. We create a 7 to 10 minutes co-op experience where the VR player works together with the players in the immersive room to raise awareness and create conversation about environmental challenges in Amazon. Thank you, and we are open for questions. Yes.
So imagine that I walk into the room. What is my onboarding to get into your experience, and what happens if I suck at rowing?
So the question was, how are we getting the guests into the room and how are we getting them onboarded to the experience? So typically in the global language and culture room, Stefan, our client, will be leading a lot of the experiences, walking them in. And so we hope by the end we can provide documentation and we can work with Stefan more on how we can onboard all the guests within the immersion room safely and accurately so that they can enjoy the experience. Yes, Ralph.
Why why is it important to have rowing activities? I mean, it seems to be the intent is to talk about other things and to teach you other sort of issues.
Yeah, so Ralph just asked a question about rowing and why do we need it? And that comes back to the idea of immersion. So when we were designing our experience, we looked to a lot of resources. One of them is Jesse Schell's lecture about educational gameplay. And we really looked at an experience he made for the Smithsonian where it's like a asymmetric experience and where they have to use communication. And while there's one player in VR, they still have simple immersive actions to keep that like sense of immersion there and keep we really strive for immersion with our experience, and we still think while we can have this educational communication aspect to our game, this sense of immersion is really a key point as well in our experience. Yes, Dave.
I'm kind of curious, what kind of conversations do you want people to have, either during this experience or after this experience?
So the question was, what kinds of conversations do we want the guests to have? Did you?
Yes, so like the tech demo that we have shown, that is kind of the in-game conversation we're looking for. They're exchanging information because of the symmetry. The player in the immersive room has more information on their end goal to create a documentary. So he'll provide information on how to make the documentary, and he'll also provide guidance to the VR player, while VR player are mostly taking out the actions and then send the video back to the immersive room player. But for the after-game conversation, that is our main goal, is to create conversation and raise awareness about the environmental challenge in Amazon.
Mm-hmm. Yeah, so our experience really, we want to have some sort of call to action at the end. However, with our target audience being students, we can't ask too much of them, but simply having a conversation about the effects of deforestation and pollution really is maybe a small domino in a larger chain of dominoes, and like what that can lead to in conversations and maybe more research outside of the classroom space. Yes, John.
So what I'm aware of in that room, the immersion room is real tucked away in the corner, it's kind of small, and the VR version is going to be outside of the room, is that correct?
Not outside of the room. So we did measure the, what John is asking is in regards to the dimensions of the room, the space, where are the guests positioned, and how we've measured the room. It's approximately 8 feet wide by 11 feet deep, and the idea is they're both be in the room, and the immersion room guests will be like under the projectors, like right up towards the wall. They can get pretty close to the wall because it's front wall projection, so they won't touch it. And then the the VR guests will be in the back. Sorry. Mm-hmm. Yeah. Yeah. There are glass windows, and so you can be able to see from the outside. Pardon me? Correct. Yes, Heather.
We're at time, sorry.
If you'd like to email us, please feel free to. Thank you. Thank you, everyone.
Thank you.
So welcome to our presentation. We are Team Big MR, and I am Hui Jibao, the designer and producer of the team.
I'm David Morales. I'm the programmer on the team.
I'm Nolan Pearson. I'm a designer, and I'm also helping produce this project.
I'm Alyssa Tang. I'm also the programmer on this team.
So our clients of these projects are all ETC members, and we will talk about what is Big MR. Big MR is a platform that enable other creators to create experience with big and MR elements. So big means big room, which is a 30 feet by 30 feet space in RPIS here. Players will be able to walk around in this space, and it also means multiplayer. So we will have 2 to 4 players in the playtest day, and they will being able to see each other's influence to the world, and they will also need to hand off objects. And what is mixed reality MR is we will have Quest 2's pass-through camera. So it's kind of a bridge between virtual world and real world. We have also, and pass-through camera is also what our clients really like. And object checking, we have explored different kinds of object checking modes. David will talk about them later, about what we explored so far. And the matrix of Big MR are technology, documentation, prototyping, and innovation. Technologies means since we are going to explore a set of hardwares to make a platform that enable creators to use. And documentation means we will have 2 documentations and tutorials for future creators to guide them to use the platform. And prototyping means we are going to make different kinds of demos to prove that platforms works. And innovations means we are going to explore how to fully utilize the big room, the multiplayer, and the mixed reality, including object checking and pass-through camera, to make this an immersive experience. And now we will hand it to Melissa.
Hi, everyone. So our deliverables will include both the hardware and the software parts. So first, we are going to hand off several hardwares built as a platform for other creators, probably as future ETC project platforms. And we hope that should inspire new design ideas utilizing this big-scale mixed reality platform. And we will definitely build up some documentations for the other creators to have a reference. And also for prototyping, our team are also building the tech demos to prove the feasibility of this platform. And this development process will, on the other hand, give us more feedback on our platform and inspire the iteration of it. So our target users will be future ETC students and also our clients, the IT team, and also other faculty pitches. So now we're going to show 2 tech demos that we have been working on before Halves. The first one is kind of a mixed reality portal based on the Quest 2 pass-through camera. So by enabling the pass-through camera, we can see the real world, that is the RPS room here. So although it's black and white due to the tech limits for now, we expect it to be colorful in newer versions of Quest in the near future. So we can set up the improv door, this door as the physical portal into the VR scene. So by stepping outside, we can see a VR castle through the door and the real RPS room. But when stepping inside it, we can see that the whole room is decorated as a VR castle. So this one shows how the pass-through camera can blur the boundary between the real world and the VR scene. And it will enable our future game designs on this mixed reality platform. Okay, so the next demo will show our work on the networking between our players and the game objects. So this video is recorded in Nolan's view. And we can see which is headset and controllers recognized. Yeah, and they can pass the game object attached to the Vive tracker to each other or leave it on the ground for the other one to pick up. Yeah, so this demo shows our work on the networking between the Quest headsets and also the recognizing of some game objects, and that will enable future game designs that require the cooperation between multiple players.
Okay, now I will pass on to David to talk about our game tech development process.
So from the start, our clients came to us with the stipulation that we test out the Quest 2 pass-through camera to test out our mixed reality. And we found that it worked really well for us. So we stuck with that in terms of mixed reality, but we also wanted to test the object tracking capabilities. Now the Quest 2 itself doesn't have any external tracking. It has only your 2 controllers and no other objects. So we looked into new technology that we could use to track objects other than these 2 controllers themselves. So you can see we tested 5 different technologies. We tested the Apple AirTags, the Alps system, April tags, which are essentially QR codes that you can detect with a camera, the Azure Connect, which is a new version of Microsoft Connect, and Vive trackers. So what we found was that first we wanted to prioritize our accuracy, which we asked our clients what they would value most, and they told us that regardless of what technology we use, it should be accurate first and foremost. So that automatically eliminated the Apple AirTags, the April tags, and the Azure Connect, because those had low to medium reliability in the tracking that we found. And moving on from that, we tested the Alps system and the Vive trackers. And deciding between these 2, we found that the Alps system currently requires an iPhone to track position, but it would require 2 iPhones per object to track position and rotation, whereas the Vive trackers would only require 1 Vive tracker per object, which is much cheaper in terms of cost. So we ultimately went with Vive trackers for object tracking, and as you can see in the demo we presented earlier, it works fairly well. So some of the feedback we got from quarters was to focus on health and safety in our experiences, so making sure that our experiences don't obscure anything that a guest would need to know about their reality. So making sure that they don't lift something heavy, expecting it to be light, or tripping on objects on the floor that were obscured by VR objects, and things of that nature. In addition, we had a lot of faculty that told us about the Alps system, which informed our testing on object tracking. Ultimately, we decided that it was too expensive for us currently, but in the future, once the technology becomes more cost-effective, we can see that as a viable option. And in addition, we got feedback from Mike Crystal, who recommended that in order to playtest what is essentially a platform rather than a full experience, we can do a game jam with creators where they would develop content on our platform to see how well that platform can support new creators creating their own content. In terms of our plans moving forward, now that we have all of our tech sort of working, we want to make it more stabilized so that in the future people can develop content for it without having to debug. Then we want to design a few demos for this tech. We want to playtest those demos with real users and use those playtests to inform our hardware. So we'll go back and iterate on our platform to make sure that the experiences that we've created work well in terms of our technology. Now I'll pass it to Nolan to talk about our design.
Thank you very much, David. So these are a couple of the design principles which we discovered through just testing the hardware and feedback that we received. As David had mentioned, health and safety is one of our first and foremost principles here throughout all of the tech demos. We don't want to play with the guest's perception of weight or size of an object where they may misjudge something and possibly injure themselves. Our purpose of the tech demos is we want to give guests a reason to fully use the 30 by 30 foot space. We want to give them reasons to move around, and handing off objects between them, just increasing the interaction between the guests. And then, as I said, limiting the visual cues around interactable objects. Some of the inspirations that we received here from feedback and from our clients. The first image we have here is a previous ETC project, Impressions. The objective of Impressions was remotely networked headsets, having players work on a painting together. The second example we have here is a VR game called Space Pirate Trainer, which features a game mode that uses 30 by 30 foot space and has locally networked headsets, so 2 players working together to accomplish a goal. And then the final third one we have here is the holodeck from Star Trek, as Alyssa had shown in her example. So the progress of the design has been really interesting. The images we have here are just some examples from different design documentations that Weijie and myself have compiled. We're in an interesting space here with the hardware being so novel. Before we could design experiences for it, we needed to know what the hardware was capable of, but we didn't want the hardware entirely dictating the design. So we've hit this rhythm and this good cadence where the hardware informs the design, which informs the hardware, which informs the design, et cetera, et cetera. So our plans for Playtest Day in April, we would like to have guests that are over 18 with some experience with VR because of the, as we said, the novel nature of this hardware. We think it would be helpful to have already experienced something similar. We will be working here in the RPIS. We want to have a minimum of 2 guests locally networked. We could design an experience up to 4 guests. We need to stress test the hardware to make sure it is capable of that. And we think the tech demos will be around 10 minutes. So in summary, Big MR is a location-based, large-scale, multiplayer, locally networked headsets using mixed reality of object tracking and the pass-through camera so that players are aware of the environment around them. And with that, we are open for questions and comments. Thank you.
Yes, Chris? So the question is, when we'll be ready for classroom use? Yeah. So we're hoping that we'll have the technology ready by softs so that we can have people develop content between softs and finals so that we can test the platform and make any changes that need to be done before finals. And then moving forward, it should be ready by next semester for pitches and students to use.
The summer, 16-year-olds, NHSTA, will it be ready?
It should be, yes.
Well, then come talk to me, because I want to use it.
Okay, cool.
The 16-year-olds would go crazy to use this. Right?
That's what we're hoping for, yes.
So come talk to me.
Any plans to do any larger scale demonstrations, demos, utilize the system as a team yourselves? You'll have the most time with it.
We are designing tech demos to illustrate the individual capabilities of this, the object tracking and the pass-through camera and the portal. So we're hoping that with those demos we can hand it off for a more fuller experience with other creators.
I think it's important to see how these things come together, though, and that you develop hindsight as a team. So maybe consider that.
I'm kind of curious, what has been surprising or harder than expected in this?
So a lot of the technologies that we tested in object tracking were not as reliable as we expected them to be. We have worked with some of the technologies previously, but a lot of them are very specific and don't work in a 30 by 30 area, which the April tags and the Azure Connect only really have an effective range of 15 feet, which is too small for us. And trying to find technology that actually works at that large scale was very difficult because cameras just, most cameras can't see that far.
I think we have time for one more question. No. Steve, yeah.
Okay, just a comment. You did eventually address this in what you were saying in your presentation, but make sure the slides that say multiplayer say co-located multiplayer, because usually multiplayer means online.
Yeah. All right, thank you.
And that's an important distinction here.
Yes, these players will be in the same space. And that is one of the novelties of this, in that we looked at the past ETC project, Immersion, which accomplished networked Quest 2 headsets, but the goal of that was to have people not have to be in the same place. So this is sort of the opposite in that we want them to be in the same place.
All right, that is time.
Thank you very much.
Thanks.